So guys, before starting the main concept of our video, let me start my video with an interesting question to you. Okay, so basically this is the pen. Okay, I have given you a pen. Okay, I am asking you, what would be the color of the refill? I repeat, what would be the color of the refill inside this pen? Yes, you want me to ask the question once again? So this is the pen which I am going to give you, and I am asking you, what would be the color of the refill in this pen? Most of you may be guessing, but some of you, a few I think, will be saying that, sir, how can we see without writing? Alva, some of you are able to say that, so how can we say what would be the color of the refill without writing? That means what? Those who are guessing it, you only know that we are guessing. Some may be thinking by the exterior part of this exterior color of the pen, you may be predicting or guessing that the color of the refill may be black. Or one who is using the octane pens, they would be aware that, okay, even though the exterior part is black, but the interior will be, the refill will be blue. So these are the mere guess. We can get the confirmation only when I remove its lid and write something. Alva, and write something. So when I am having the close view, yes, don't see my name, just see the color of this pen, which is blue in color. So what I came to know, yes, though the exterior part of this pen was black, but the color of the refill is blue. So now it is a confirmation for me. If again I am asking you a question, after doing all these experiments, what is the color of this refill? Or what is the color of the refill inside this pen? Easily one can say it is blue in color. So how it is related to today's video will be a big question mark. Alva. So guys, why I am saying this, because even when we were doing the salt analysis, first we were observing something. Then once again we were cross-checking our observation through a confirmatory test. How's Alva? In the same scenario, till now we have studied about alcohols, and we came to know that there are three different types of alcohols. What are those? Primary alcohol, secondary alcohol, tertiary alcohol. The major differences between the alcohols. Now of course the question arises within us, if you would be given three beakers, and in all these beakers you are having their respective alcohols, but you have not been said which are those alcohols, in which you are having the primary, in which you are having the secondary, and which one you are having the tertiary. But I have given you the task that you should say to me what type of the alcohols are present in these three different beakers. Of course, as some of the fellows guessed by using this pen that, okay, it may have black, you can also guess, okay sir, this is the third beaker, you are having tertiary, this is my guess. This is second, you can have a secondary, this is first, it is a primary. It would be a guess. But I want to confirm that whether my guess is right, then how can I do it? So guys, in today's video, we are going to look after that confirmation test for identification of the three different types of alcohols: primary, secondary, and tertiary alcohols. Okay, let's begin with it. So basically, I would just like to recall one of the reaction which we have studied in haloalkanes and haloarenes, and moreover it was a named reaction. That was what? Grooves process. Yen madri now Grooves process alli? Yes. So when alcohol was treated in the presence of concentrated HCl and anhydrous zinc chloride, we got as what? Yes, an alkyl chloride plus we got as water. So why I'm saying this? Because this is the reaction which is going to be seen in this video as an identification test. And that test name itself is called as Lucas test. Lucas test. So when I was dealing with this reaction in haloalkanes and haloarenes, I have said you that this reaction, this part, that the reagent is going to appear once again. And here is that where we are seeing the appearance. So basically in this Lucas test, first important thing one has to know what is called as Lucas reagent. Lucas reagent. Remember, whenever you have been asked to give a Lucas reagent, it's simple, but you have to remember. Concentrated HCl, please mark my words, concentrated HCl plus anhydrous zinc chloride plus anhydrous zinc chloride. The combination of this part is called as what? Lucas reagent. I repeat, the combination of concentrated HCl and anhydrous zinc chloride is called as what? Lucas reagent. Now the task begins, that how can we identify which is your primary, secondary and tertiary alcohol using this Lucas reagent. Before going to that part, first two important things you should remember. What is that? With the Lucas reagent, I am going to treat my respective alcohol. Why? Because in Lucas reagent, alcohols are soluble. Alcohols are soluble in Lucas reagent. That means what? You can take primary, you can take secondary, you can take tertiary alcohol. All the three types of alcohols are soluble in Lucas reagent. That means what? They are somewhat reacting. But we know one important thing. What is that? Whenever an alcohol is reacting with a concentrated HCl and anhydrous zinc chloride, same the Lucas reagent, it is going to give you an alkyl chloride, alkyl halide. So second most important thing we have to know that whatever the halides you are getting, whatever the alkyl halides we are getting, they are insoluble. They are insoluble in Lucas reagent and they form precipitate. So utilizing this concept, that is your second concept, that is what? Alkyl halides which will be obtained as a product, what they are? They are insoluble in Lucas reagent. And overall they are insoluble. What they are going to provide you? The precipitate. So of course now the question arises, okay sir, you take primary alcohol, you take secondary alcohol, even you take tertiary alcohol, not a matter. All the three alcohols are soluble. Of course they are going to give you the alkyl halide. And then what is the reason you can say that how can we identify over here, alva? Yavade alcohol tagondru alkyl halide kotte kodutte. Alkyl halide kodta untade artha enu? They are insoluble. Of course they are going to form a precipitate. In all the three types of alcohols also you are going to get the precipitate. Then how can we identify will be the major question. Remember guys, very much important. So when alcohol plus your Lucas reagent is taken, alcohol and your Lucas reagent is taken, let us see the observation in primary, secondary and tertiary alcohol. That means when this alcohol is a primary alcohol, what would be the observation? When it is a secondary alcohol, what will be the observation? When it is a tertiary alcohol, what will be the observation? Remember, when our alcohol is treated with a concentrated HCl and an anhydrous zinc chloride, and if the alcohol used is a primary alcohol, no turbidity appears. No turbidity. Turbidity means nothing. Once again, like a precipitate itself. No turbidity appears at room temperature. Very much important it is. So what they are saying, no turbidity appears at room temperature. or in some of the books they can also say it as turbidity appears. Turbidity appears when, yes, when we are going to increase the temperature. That is done by how? Only by heating. So turbidity appears only on heating. Only on heating. What does this mean then? So of course when primary alcohol is reacting with a Lucas reagent, remember it is not going to give you the respective alkyl chloride at room temperature. When the product itself has not been formed, where does the turbidity should come? That is the thing we are seeing here, that when primary alcohol is treated with a Lucas reagent at a room temperature, no turbidity appears. But in case if you are going to heat this mixture, that is primary alcohol plus Lucas reagent, and you are going to heat it, what happens? As soon as the temperature increases, we could see the turbidity appearing. So this is in the case of your primary alcohol. So when I come with respect to my secondary alcohol, what happens? Remember, in secondary alcohol, turbidity appears after 5 minutes. After 5 minutes. Are you able to see the difference? Though in all the cases we are getting the turbidity, but we are seeing the rate at which the turbidity is appearing. That itself is our identification. Okay, are you getting my point? When we saw primary alcohol at room temperature, there was no PPT or no turbidity. But in case if it was a secondary alcohol and you are going to treat it with a Lucas reagent, we are able to see the turbidity only after 5 minutes. Here what is the thing we can notice? In chemistry we need patience. Alva? So ಇಲ್ಲಿ turbidity ಬರಲಿಲ್ಲ, ಹಾಗಂತ ನಾವೇನು ತಿಳ್ಕೊಬಿಡ್ತೀವಿ, ಈಗ ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ ಟರ್ಬಿಡಿಟಿ ಬಂದಿರಲ್ಲ, ಎಲ್ಲಿವರೆಗೆ 4 minutes 59 seconds ತನಕನೂ ಬಂದಿರಲ್ಲ. So we should not judge that it is a primary alcohol. Instead we have to wait till 5 to 7 minutes so that we have to check out whether it may be a secondary alcohol. So that is what the chemistry teaches us, the patience level. Okay, you should not be in a very hurry-burry. Whenever you are doing a salt analysis also, you have to wait. You have to wait for 10 minutes to see whether the reaction is going on, whether the reaction has proceeded. Then only you have to discard whatever the solution is given to you. These are the simple terms what we have to see even though when we are studying the theory part. Okay. So when we are taking your secondary alcohol and treating it with a Lucas reagent, what happened? Turbidity is going to appear only after 5 minutes. Now you can only say for tertiary, what would be happening? Yes. So turbidity appears immediately. Turbidity appears immediately. Alva. So now you can see the difference. How can you identify the 3 types of alcohol? So in case, if this beaker was having a primary alcohol and to this one you are going to add the Lucas reagent at a room temperature, what would be my identification test or the observation? There will be no turbidity. If the second beaker was having a secondary alcohol, to this if I have added my Lucas reagent at a room temperature, what is my observation? Yes. So turbidity is appearing after 5 minutes. Alva. So if the third beaker was having a tertiary alcohol, what will be my observation when it is added with a Lucas reagent? Yes. The turbidity appears immediately. Turbidity appears immediately. Are you able to see the things? So for that reason I have given you this example. So only by the practical evidence, Alva, when I said that what would be the color of the refill, we get the confirmation only when I took out the lid and wrote something. So only through writing I came to know it was having a blue color. That is what your practical experience. Practical confirmation only gives us the final confirmation of our result. Whatever may be the guess, that can't be said as it is a 100% confirmation. Only through the practical evidence we can say that whatever was our judgment was, whether it was right or wrong. So same here also, when it was a primary alcohol, you are going to treat it with a Lucas reagent, turbidity will not going to come. Okay, at room temperature. If it is a secondary alcohol you are treating with a Lucas reagent, what will happen? Turbidity will appear only after 5 minutes. If it was a tertiary alcohol, turbidity is going to appear immediately. Is that clear? Okay. Now come let us have some additional information. So remember, so basically now whatever we have read, it will be coming under the concept what? How does your alcohol reacts with hydrogen halides. Hydrogen halides. Okay, alva yakandre iva tagondirirodu HCl. So it could come under the concept what? Alcohols reacting with a hydrogen halide. But do remember, one of the important tests in exams, they can ask you, give Lucas test or give the Lucas reagent. Lucas reagent means you have to mention concentrated hydrochloric acid. I repeat, concentrated hydrochloric acid. Don't write just the hydrochloric acid. It is not a worthful answer. You have to mention concentrated hydrochloric acid plus anhydrous zinc chloride. I repeat, anhydrous zinc chloride. The overall mixture itself is called as what? Lucas reagent. Is that clear? So therefore we are coming under the concept of alcohol reacting with hydrogen halide. And do remember, so this is a reaction which is going to be seen under the cleavage of which type of bond, whether OH or CO. Let us see the reaction. Where I have seen, yeah, this part. If I am going to use CH3OH plus concentrated HCl in the presence of my anhydrous zinc chloride, what I am going to get? CH3Cl. That means what? The bond between C and O has been broken off. So this is a reaction which we are going to study under cleavage of CO bond. Very much important. Any type of a question can arise. What type of a cleavage we are seeing when alcohol is reacting with hydrogen halides? Okay, because in alcohols we have seen that alcohols are giving certain reactions in which there will be a cleavage of O and a H bond. Alva. There we have seen in the acidity part. Acidity the H plus korte, that was coming under that part. Here we are going to see that how does the cleavage is taking place between that of your C and the O bond. Is that clear? And one of the most important thing I would just like to ask, the reactivity of alcohol or phenol is more towards the cleavage of CO bond, That means CO bond cleavage in a ಯಾವ reactions ಉಂಟು ಅದು alcohol ಬೇಗನೆ ಆಗುತ್ತೋ ಅಥವಾ phenol ಬೇಗ ಆಗುತ್ತೋ. Are you getting my point? So if you have been given with alcohol and a phenol and have been asked whether CH3OH will break at a faster rate or C6H5OH will break at a faster rate. E bond ಬೇಗ ಮುರಿತದೋ E bond ಬೇಗ ಮುರಿತದೋ? Judge it. I am not asking for OH, I am asking for CO bond. Remember guys, always your alcohols will break at a faster rate. Why? Because when you see this phenol, there will be a double bond character between C and O. To the resonance we have seen it. What will be there? There will be a double bond character between C and O. And we know that as soon as the bond order increases, what happens to the bond dissociation energy? It also goes on increases. Alva? Single bond muriyadu sulba. Double bond muriyadu solpa kasta. More bond muriyadu hinnu kasta. The same scenario. In alcohols, there will be only a single bond between C and O. So therefore, the breakage of CO bond in alcohols, normal aliphatic alcohols, is simple. But when it comes with respect to that of your phenols or aromatic alcohols, so it will be somewhat difficult. Why? Because there will be a double bond character between C and O. Is that clear? So this was an additional information which I would like to give in this part. So today one of the most interesting part we have seen that how in laboratory you can easily give an identification test for identification of primary, secondary and tertiary alcohols and using your Lucas reagent. What is Lucas reagent? It is the combination of your concentrated hydrochloric acid and anhydrous zinc chloride. Now let us come with the most important part. let us see certain uses of our alcohol. So basically, when we are talking about the uses of alcohol, I would like to mainly concentrate upon two important alcohols. One is my methanol, okay, and one more my ethanol, okay, OL. Don't write AL, it will be an aldehyde. Where you have to write OL itself, you have to write. Okay. So basically, first of all, we'll talk about methanol. So interesting fact, first we have to see that how they will be prepared. Alva. So basically our methanol is having the formula as what? Yes, meth is there, which means one carbon atom. Ane is there, which means single bond between all the four bonds will be single bond. And you will be having an all over there, the hydroxy as a functional group. So CH3OH will be our formula. So basically this methanol is also called as what? Wood spirit antanu heltivi. Enanta heltivi? Wood spirit. So generally they are prepared through the distillation of wood. Distillation of wood. So hege now methanol na prepare madadu andre by the distillation of wood. Hence it has got the name as what? Wood spirit. So basically by treating your carbon monoxide with hydrogen. Please remember carbon monoxide. Some of you write carbon monoxide as like this. It is wrong. Why? Because it represents your cobalt, not carbon monoxide. Whenever you are writing a carbon monoxide, the same length or the same size should be between your carbon and your oxygen. C ಎಷ್ಟು ದೊಡ್ಡಕ್ಕೆ ಇರುತ್ತೋ oxygen ಅಷ್ಟೇ ದೊಡ್ಡಕ್ಕೆ ಇರಬೇಕು. Okay? Don't make silly mistakes. So carbon monoxide plus your hydrogen. Remember, these are very much important. In the presence of zinc chromic oxide, ZnOCr2O3, 200 to nearly 300 atmospheric pressure and nearly 573 to 673 Kelvin temperature. So how can we prepare our methanol? By the reaction between your carbon monoxide and hydrogen in the presence of your zinc chromium oxide at a pressure of nearly 200 to 300 atmosphere and a temperature of 573 to 673 Kelvin temperature. So whatever the alcohol we are going to get will be our methanol. Coming to its uses, basically they are used as a solvents in paints and varnishes. Solvents in paints and varnishes. And also the major important use I would like to focus is they are used in the preparation or even say you can say manufacture of your formaldehyde. Formaldehyde means methanol. AL alva methanol HCHO. So preparation of our formaldehyde. Coming with respect to now second alcohol, that is our ethanol. Yes, of course you're going to be knowing fermentation process alva. So yavatagli grape wine ene madru kuda ondu ಹೇಳ್ತೀವಿ alcoholic content irutte. Why? Because whatever the grapes or wine we are going to prepare, the wine what you are going to prepare from the grapes, it is through your fermentation, and through that fermentation what type of an alcohol a kick barutte anta heltaralla, that is only obtained by the presence of this alcohol content, which is your ethanol. So basically it is also produced in our body too. That is how, let us see. So basically they are produced by fermentation. So basically it is C12H22O11. What is this? Yeah, the sucrose. Okay, it is undergone an water hydrolysis in the presence of our enzyme invertase. First ಏನಾಗ್ತಾ ಉಂಟು invertase enzyme first ಈ sucrose ನ break ಮಾಡುತ್ತೆ. break ಮಾಡಿ ಏನು ಕೊಡುತ್ತೆ? C6H12O6 plus C6H12O6. Whether both are same compounds? Of course not. One would be a glucose, another will be a fructose. So many times I have said this. So they are both are what? Functional isomers. Why? In glucose we'll be having a one type of a functional group, in a fructose another type. ಇದರಲ್ಲಿ ನಮಗೆ aldehyde group ಇದ್ರೆ ಇದರಲ್ಲಿ ನಮಗೆ ketone group ಉಂಟು. But both are having the same molecular formula. Is that clear? So once this glucose and a fructose is formed, what will happen? Once again, now this will be C6H12O6 will be broken off in the presence of our enzyme zymase. Can you see specific enzymes, lock and key system? Ee reaction ಆಗಬೇಕು ಅಂದ್ರೆ ನಮಗೆ invertase ಇರಬೇಕು. Zymase ಇದ್ರೆ ಈ reaction ಆಗಲ್ಲ. When we were studying the surface chemistry, I have said enzyme action alwa, lock and key system. A particular lock can be opened through a particular unique key itself, alwa, master key, unique key. Here also invertase only can carry out this reaction, whereas zymase can carry out only the final part, that is conversion of your glucose or fructose to ethyl alcohol. That is, you will be getting as a C2H5OH plus carbon dioxide. Is that clear? Balanced? 2 2s are 4, 5, 6. Yes or no? So by this way, so this is the process actually which is happening in your fermentation. Are you able to see? So coming with respect to the uses part, so basically here also ethanol is also used as a solvent in paint industries, and also they are majorly used in the preparation of our carbon compounds. Are you able to understand? So we have seen the two important types of our alcohols and their uses. But remember guys, when you are reading this chemistry part, one of the basic thing we have to know about alcohol. So whenever you are entering the lab, or whenever you are entering to some companies where you are having many chemicals, one of the major chemicals, as I have said, in paint industry, if you are going, they will be requiring the major important component as an alcohol, because it is a solvent in which they will be preparing the paints. Alva, solvent and paints namagu gotti yav taradadu navu nodidvi. It is a type of what? In a surface, this one we have seen in colloids. So dispersion medium ಗೆ ನಮ್ಗಲ್ಲಿ ಏನ್ ಬೇಕಿರುತ್ತೆ, alcohols ಬೇಕಿದ್ದೇ ಇರುತ್ತೆ. So ಅವಾಗ ನಾವು ಏನ್ ಮಾಡ್ಬೇಕಲ್ಲಿ, so whenever you are entering the companies or even in your labs, we have seen an alcohol. Alva, we have seen alcohol. But do remember, it is not the same alcohol what is being sold in your wine shop. I repeat, it is not the same alcohol what is being sold in your wine shop. So then what is the difference between both? Remember, in companies, whatever the alcohol we are using, it is called as what? Denatured alcohol. Denatured alcohol. By the name itself you are getting, we have altered the nature of the normal alcohol. That is the reason we are using the word as what? Denatured. So what is this denatured? Basically, of course, the commercially prepared alcohol, the commercial alcohol is our ethanol itself. Okay, the commercial alcohol which we are obtaining from the wine industries or alcoholic beverages, commercial alcohol will be your ethanol, which nearly 70 to 90% will be our ethanol. But when we talk about this denatured alcohol, remember, this alcohol, that is your ethanol, will be mixed with copper sulfate. Why? Because I will be saying this. Let me first say what is there contained over there. Copper sulfate plus pyridine, and most important thing is 5% methanol. 5% methanol. So what we are doing is, whatever the alcohol which is present in the industries, they will be of poisons. They will be very hazardous. And that hazardous is coming from 5% methanol. Generally we talk about denatured alcohol as what? Ethanol and a 5% methanol. But I am giving you an additional information. Along with that one also, we are also adding a copper sulfate and pyridine. Why? I will just see. Before saying the reason for these two, of course everybody have seen an alcohol in our lab. Have you seen the lab? In lab we have seen the color of the alcohol. What is the color of the alcohol? Yes, it is colorless. First it is what? Colorless. What is the smell of the alcohol? Yes, boys, what is the smell of the alcohol? Yeah, you will now itself, by imagining its smell, you will faint off. That means what? It is having a pleasant smelling. It is having a pleasant smelling. So of course, whenever in factories, we know that there will be many workers, they will be having a workload, tension and all those things. So what they will think, of course in factories also we are having the alcohol, so we can drink it. So in order to avoid certain such circumstances, in order to avoid such nuisance in the factories, what they will do in the factory, the managers or whoever is supplying the alcohols, in order to avoid such nuisance, whatever the alcohol they are obtaining commercially, yes, first they are going to add copper sulfate. Why? Because it was indicating for the workers that whatever the alcohol we are using for drinking purpose, that is what in the factory, or whatever the alcohol we are using in factory, it is poisonous. That is how we come to know first important thing, by making it from the colorless to color. So when copper sulfate, why copper sulfate is added? To give color. Of course, alva, it will give which color? Blue color. Koda chances irutte. Copper sulfate means it is blue color. First, copper sulfate is added to give color. It's an indication. Alva, on the bottle bardidare, adu mele ethanol bardidare andre artha enagutte, hoಗ್ಫೋಸಿನ alcohol ಕುಡಿದು ಬಿಡೋಣ ಅಂತ ಅನ್ಸುತ್ತೆ. ಆದ್ರೆ ಆ ethanol ಒಳಗೆ ಏನಾಗಿರುತ್ತೆ? ಫಸ್ಟ್ ಕಲರ್ ನೋಡ್ತಾರೆ. ಅವಾಗ ಅವರಿಗೆ ಏನು ಗೊತ್ತಾಯ್ತು? ಓಕೆ, ಈ ಆಲ್ಕೋಹಾಲ್ ಗೆ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ನ ಆಡ್ ಮಾಡಿದ್ದಾರೆ. Okay, once they will see a bottle of ethanol having a blue color, it will be an indication for them. What is that? It is poisonous. That is first part. To give color, we are adding copper sulfate. But some fellows will be much reluctant. Even though they see the color, they will be having something going on in their mind. Okay, I will drink it. Next comes with its pleasant smelling. So what I will do, I will make it a somewhat foul smell. In martini, a smell na tegdi tumbane kett smell barange one martini. Adurke en martini nanu, I will be adding pyridine. Why pyridine is added? To give the alcohol a foul smell. Foul smell. Not a good pleasant smelling irala. Kettu vaase barake en marte pyridine na add martini. Are you able to understand? Even now also they want to drink. Okay, for that purpose, in order to avoid it completely, what I will do, I will be adding now my 5% methanol. Very much carcinogenic. Why? I will say it. So when this methanol enters to your body, remember, through the enzyme actions, this methanol undergoes oxidation. What it will be happening? Methanol undergoes oxidation. And we know, when alcohol undergoes oxidation, what will happen? It will form aldehyde. So as soon as your methanol enters the body, first it will undergo oxidation and it will be forming you what? Methanol. Okay, alcohol is the aldehyde by some suitable enzyme in your body. It will not stop over here. Once again, that enzyme will further oxidize your aldehyde to methanoic acid. Are you able to see? This methanoic acid, once it has been formed in our body, it is very, very poisonous. At an instant itself, it will be resulting in blindness. Complete nama kannu katle agbidutte. It will be resulting in blindness and result to that of your even death. So for that reason, we are adding this methanol. Are you able to see? Just to avoid that, nobody should use this in laboratory, whatever the alcohol is there, for their personal purpose. So what we are doing in a denatured alcohol, even though you are having this commercially alcohol, to that one we are adding our copper sulfate, which promotes the color, because normal alcohols are colorless. Yes. To that one we are also adding pyridine in order to generate a foul smell and make it more poisonous. We are adding what? 5% methanol. How it is poisonous? As soon as this methanol enters to our body, it will first get oxidized to your aldehyde, that is your methanol, and further it oxidized to your methanoic acid, this formic acid. Once this formic acid is generated in our body, first it will cause blindness and finally it will be resulting in death. Now the question arises. Sir, if there are fools like us Okay, if there are fools like someone, is there a possibility, even though they drink that denatured alcohol, is there a possibility that we can give them any first aid or something like that so that we can make them alive once again, or we can treat them? The question arises, if some fellow has drunk your denatured alcohol, is there any treatment so that we can save him? Of course there is. What is the reason? Of course God also knows. So He has made one system within us. What is that? In our biological system, the relative affinity of alcohol dehydrogenase, or we can say in simple words, the body responding to the ethanol, is more when compared to that of your methanol. Why I am saying this? Generally what happens? For example, if a fellow has drink this denatured alcohol, of course in his body now methanol content is there. Okay, it is now getting converted to formic acid. Okay, one process. This is first process. This is my second process. Only when it is with respect to the second process, it will lead to blindness, and then now also we are not treating him, it will lead to death. When concentration of formic acid goes on increases. So one method is what? I have to block the path here itself. Formic acid bodily utbhava agle illa andre, we can make that patient to survive. So how it is possible? By giving through intravenous ಮೂಲಕ ethanol na ವಾಪಸ್ ನಾನು ಕೊಡಬೇಕು. Are you getting my point? ಏನ್ ಮಾಡ್ತಿದ್ದೀನಿ ನಾನು patient ಗೆ ಇನ್ನೊಂದ್ಸರಿ ನಾನು veins ಮೂಲಕ ethanol ನ infuse ಮಾಡ್ತಿದ್ದೀನಿ. So ಅವಾಗ ಏನಾಗುತ್ತೆ, as we know that our biologically our body is such a way that it will first treat our ethanol, then only it will go for the methanol. So ಏನಾಗುತ್ತೆ, of course formaldehyde ಇಲ್ಲಿ ಆಗಿರುತ್ತೆ, ಇದನ್ನು ಆಕ್ಸಿಡೈಸ್, ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ನ ಆಕ್ಸಿಡೈಸ್ ಮಾಡಿ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ಏನ್ ಮಾಡುತ್ತೆ, ಅದು ವಾಪಸ್ಸು ಆ ಎನ್ಸೈಮ್ ಫಸ್ಟ್ ಈಗ ಎಥೆನಾಲ್ ನ ಆಕ್ಸಿಡೈಸ್ ಮಾಡಿ ಅದು ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಆಲ್ಡಿಹೈಡ್ ನ ಕೊಡುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ಒಂದು ಟೈಮ್ ಲ್ಯಾಪ್ಸ್ ಆಗುತ್ತೆ ಈ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್ ನು ಫಾರ್ಮ್ ಆಗಕ್ಕೆ. ಈ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಆಗ್ತಾ ಬರುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ವಿ ಕ್ಯಾನ್ ಮೇಕ್ ದಟ್ ಪೇಷಂಟ್ ಟು ಸ್ಟೇಬಲ್. ಪೇಷಂಟ್ ಏನಾಗುತ್ತೆ, ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್ ಗೆ ಬರುತ್ತೆ. ದಿಸ್ ಇಸ್ ದಿ ಓನ್ಲಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಇಫ್ ಅ ಫೆಲೋ ಡ್ರಿಂಕ್ಸ್ ಅಂಡ್ denatured alcohol. What you have to do, you have to infuse through his veins your ethanol. Why I am saying this? Because in our body the ratio of the alcohol dehydrogenase is 20:1. That is, of your ethanol is to methanol content. Ethanol ಗೆ dehydrogenation ಆಗ content ಜಾಸ್ತಿ when compared to methanol. ಆ reason ಇಂದ methanol ಇದ್ರೂ ಕೂಡ when ethanol enters to your system, our enzyme, instead of converting your formaldehyde to formic acid, it will convert your ethanol to convert its respective aldehyde. That is your ethanolic convert ಆಗುತ್ತೆ. So ಅವಾಗ ಏನಾಗುತ್ತೆ, formic acid in a concentration time to time ಕಮ್ಮಿ ಆಗ್ತಾ ಬರುತ್ತೆ. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಆಯ್ತು ಅಂದ್ರೆ there is a chance that your patient can survive. Is that clear? So very much important to know about this denatured alcohol. Okay, it is not the normal alcohols what is being supplied in your wine shops. Okay, it is completely different. That alcohol will be added with a copper sulfate. Why? To give the color, indication ಕೊಡ್ತಾ ಇರ್ತಾರೆ ಅಲ್ವಾ, ಗೊತ್ತಾಗಬೇಕು ಇದು ಪಾಯ್ಸನ್ ಅಂತ. And also pyridine, because it will be having a foul smell, and to make it more poisonous we are also adding a methanol. So whatever the system we have seen over, it is only happening in our body. Even though we can use it, it is not change ಏನೋ ಆಗಲ್ಲ ಕಂಟೆಂಟ್. ಎಲ್ಲಿ ಆಲ್ಕೋಹಾಲ್ ಯೂಸ್ ಮಾಡ್ಬೇಕು ನಾವು, we can easily use ethanol ಯೂಸ್ ಮಾಡ್ತೀವಿ, methanol ಯೂಸ್ ಮಾಡಬಹುದು, ಪ್ರಾಬ್ಲಮ್ ಏನಿಲ್ಲ. ಕೆಮಿಕಲ್ಸ್ ಅಲ್ಲಿ ethanol methanol ಪ್ರಾಬ್ಲಮ್ ಬರಲ್ಲ. ಆದ್ರೆ when that enters to our system, of course we have seen what is the major problem. So guys, and moreover boys, be aware of it. Okay, so in our next we are going to see certain different reactions for our phenols.